1.8, general form of a line.
Wow!
Yeah, let's go. So, we have already looked at two different forms of a line, or an equation for a line that we've seen. So it's been the slope point form, as well as the slope intercept form. But here is a third form for you to tinker with, and it is the general form. The general form of equations will have a couple of little things that we want to keep in mind. For starters, all of the variables and all of the constants, aka numbers without variables, will be on the same side of the equation, meaning that your other side is going to be equal to 0. Okay? We are only going to have integer values, so anything with fractions we're going to make into an integer. So those are our positive and negative counting numbers. And our leading coefficient's got to be positive. Oh yeah. So general form is going to look like this. We're going to have ax plus by plus c is equal to 0. And notice when we've written down this general form, our capital B is different than that lowercase b than you would have seen in slope-intercept form. It does not represent the same thing. A, B, and C are just integers. So A, B, and C are integers, and we could say they're elements of the integers, right? And integers are represented by our double line Z. And our leading coefficient, which is A in this case, has to be not equal to 0, so A cannot be 0. And A has to be positive, so it has to be greater than 0, which means that it is positive. Did you feel? All right, so what we're going to do is we are going to convert everything into general form. So we're going to move everything over to one side. We're going to make sure our coefficient, so anything that comes before x, is positive, and then all of our numbers are integers. So for starters here, obviously start off by picking a color. I have my a value, that number 2 before the x, is already positive, so it makes logical sense to move everything else to my right-hand side. To do that, I have a y I want to move. I'm going to subtract that y from one side, subtract it from the other to give me 0 on the left. And then I get 2x minus y plus 3. In general form, we like to have our first coefficient, a, be first. Then the coefficient with y be second, and our constant term, our 3, be last. And that's actually it. So that's, so general and so nice. Who wants to go next?
Oh, me.
Okay.
I would love to. Okay, so this next example, very similar to last time, but you're going to notice, whoops, that's the wrong way. Okay, you're going to notice that if you take a look here at that a value, that's the coefficient on x, it's negative. And because we want it to be positive, then I am going to move everything over to the left to achieve that goal. Whoops. Okay, so we're going to add 3x to both sides, and we're going to subtract 4 from both sides to move it all over. So that's going to cancel, that's going to cancel. That leaves us with 0 on the right, which is great. That's what we want. So everything is on one side and 0 on the other. So now we get left with positive 3x, which is beautiful. We have a positive a value. Then we already had that y to begin with on this side, so we're going to keep it there. And then last but not least, we have that negative 4, which we also just moved over. And again, keeping that in the ax plus by plus c order. So x is first, y is second, and the constant is last. Then we're going to double check that all of our coefficients are all integers, which indeed they are. We have coefficient of 3, coefficient of 1, and then negative 4. Those are all integers. We're good to go. That is a final answer.
Me. Oh, sure, give me the one with fractions. I got this. But I got this in blue. So we're going to follow the same processes, punch everything onto the same side, make sure all of our coefficients and constants are integers. Super duper, pooper scooper. From an efficiency standpoint, if you can do these steps without having to say this business on each side, it can save you a little bit of time. Now, having said that, if you look at this and you can't mentally handle those steps, then absolutely write them in. Actually tell yourself that yes, you are adding 2/3 to both sides. And that you're subtracting 1 from both sides. Show that if you need to, but if you can do it without doing so, then do it without doing so. That's that business. Any poops, I'm going to add 2/3 x to both sides. I'm going to subtract 1 from both sides. And that gives me something like this. Wow. Wow. That's just as many steps as in the previous questions. I guess I'm done. Right, everyone?
No.
I'm not. Because this is not a whole number. That is a fraction. So I'll multiply everything by 3 again. If you're able to multiply everything by 3 without saying times 3 and times 3 and times 3, that looks like a minus. Good thing I'm not writing it. Then do so. If you need to write that in, write it in. Do whatever you need to do to achieve success with this question. 2/3 times 3 is 2. 1 times 3 is 3. Negative 1 times 3 is negative 3. 0 times 3 is 0. And this one is done. You're right, that does look terrible. Put on.
Beauty. So for this next example here, you may have noticed that right now we have this y equals written in. It was just a typo with the note. So if you could please add that in now, your equation should read y is equal to negative 3/7 x minus 2. All right, and we're going to do the same thing as we were doing before, but we're going to do it in this purple. We are moving our negative 3/7 x to our left-hand side because it's negative when we want to have our final value of our coefficient of x be positive, which means we're also going to be moving over that negative 2. What Mr. Athide was saying is totally accurate, which means if you could do it without having to write all those steps down, by all means, give it a go. If you need to write those steps, you will not be penalized for doing so. Do whatever floats your boat. So if I add 3/7 x, I will get 3/7 x. And I still have y on the side, so I'll get plus y. And I'm adding 2 to both sides, which means I will get plus 2. And on my right-hand side, I will end up with a 0. Although my a coefficient is already positive, that was not the only restriction. I need to make sure every single coefficient is a integer value, which means 3/7 not going to be great for us. To get 3/7 become an integer, we are going to multiply all of our terms by 7. So that includes 3/7, that includes the 1 in front of the y, the 2, as well as the 0 on the other side. So 3/7 times 7 will give us 3x. Y times 7 will give us 7y. 2 times 7 gives us 14. 0 times 7 gives us 0. And then we call it a day.
All right. So I'm back. And I'm going to do this example where we're going to notice right off the bat that we have a positive value attached to that x as its coefficient. And because of that, I'm going to move everything over to the right. In essence, that just means I'm going to move the y over to the right. Okay, so subtract y from both sides leaves me with 0 on the left. And on the right, I have 4/5 x minus y plus 2. Okay, then I need to make sure that even though my a value is currently positive and everything is on one side, we do need to make sure that it's an integer value, the a value. So we have a problem spot here that we need to solve. And we're going to do that by multiplying to become an integer. So just a quick note that if there was more than one fraction in the question, so maybe y had a fraction coefficient as well, or maybe this 2 is 2/3 or something like that, then you want to make sure that you're multiplying by your lowest common denominator to make sure everything becomes an integer. In this case, we just have a denominator of 5 to worry about. Everything else is already an integer, so that makes our lives easy. We're going to multiply everything by 5. So first on the left, 0 times 5, still 0. It's awesome. Then 4/5, or 4/5 times 5 is going to give me, 4. Hard to write and talk at the same time, apparently. And then negative 1 times 5 is going to give me negative 5 in front of the y. And then 2 times 5 is going to give me 10 as a final value. And now we have fulfilled all the requirements for general form, so it is finished.
I think maybe doing one more would be useful for us. So let's do that. Oh, there's one on the page. How useful. Oh wait, was this color used? What am I doing with my life?
This one.
Yeah, that's what I'm thinking. I wanted to go with something in the red family, just kind of complete this rainbow. Yellow would be too bright, right?
Yeah.
So, that's all right. I'm going to send everything that way. Pachoo, pacha. I'm going to get rid of my fraction-y fraction. I'm going to draw a box. I'll learn how to draw a box one day. It's fine. Well, that concludes that example and this section.
So thanks for joining us.
Yes, thank you. Thank you to all of our fans. Once again, don't forget to like, share, subscribe. And then just post this on all of your social media so everyone else can view it, even if they're not in this class.
And
Yeah.
while you're waiting for everyone to see all your social media posts, do your homework.
I was gonna say, like, you could do it in class because I call it practice work, so we could do it in like if it's a work period. But right now, I guess, yeah, it's gonna have to be at home.
Adios, muchachos!